Hey there, Vince here, and welcome to another Circuit Rewind, where I like to make hybrids of new and old technology, or I guess in this case, probably old and older technology. About a year ago, one of my neighbors gave me an offer that at some point her family would be getting rid of one of their old 386 computers, and it would either go to the local computer recycler, RePC, or it would come to me to tinker with and play around with. Just before the holiday break, a couple weeks ago, they called me up and were like, hey, so we still have this offer. We want to clear out our office now. So are you still interested in the machine? And I'm like, well, it's a 386. Like, I guess I can, dink around with that. And they also mentioned they had some software with it. I'm like, all right, cool, bring it over. Let's see what you got. What you don't see right now, because it's going to be a topic for the future, is there was about 20 to 30, maybe even more big box software titles included with this machine. Just phenomenal collection. But today, that's not too much what I'm worried about. What I wanted to do is to see if the system runs, and well, I mean, spoilers, you can see it on the screen right now. I actually have it paused on part of the boot process because I want to talk about what I want to do with this machine and what it turns out what this machine really is. So this machine is the AST Bravo LC 4/33. It's a 486DX 33 megahertz processor. At least it was until I started playing with it and put something else into it. This machine came with 4 megabytes of RAM, so 4 1 megabyte sticks, like nothing really to cry home about. And it had a 2 gigabyte hard drive in it. What I wanted to do, however, was to use a bunch of compact flash cards and have an external port for that where I can quickly plug and unplug them. That way I can install operating systems on different CF cards and boot it up with one. When I'm done with it, I can power it down, swap the CF card and boot it up with another. So I can swap, let's say, between Windows 95, 3.1.1 for workgroups, NT4, or one of my personal favorites, FreeBSD. Well, a couple of problems with that came up fairly quickly. The BIOS on this thing is extremely old, and it turns out that it only allows drives for about 500-ish megabytes maximum. These right here are technically within size, but this machine came with a 2 gigabyte hard drive. How does that work if the BIOS doesn't allow it? The reason I paused the boot process right here on the screen is because this has Max Blast by Maxtor installed on it, and it's a Maxtor hard drive. And what this software does is, as you can see on the screen here, is a dynamic drive overlay. So basically, when the system boots up, it will think the hard drive is smaller. The BIOS thinks the hard drive is smaller. It's just enough to load into this program here, and then this program overrides the BIOS and basically replaces the BIOS dynamically on the fly, or at least the BIOS calls for accessing the hard drive. And then from here, this software is like, hey, I can see the full size of the hard drive, and we can have at it from there. Historically, like I said, this has a limit of about 500 megs, but there was several different limitations over the years, which you can see on this chart here, with explanations as to why each of these limitations existed. So this is all fine and dandy. I can go and set up a drive, I can get it going, I can install the software, and bam, it's working. And there's other software that I have that does the same basic thing. The problem is like how I mentioned, Windows NT or FreeBSD or Linux or other operating systems, they're not DOS based, so I can't use these utilities with them. So let's go way further back in time. So this is a 486, but what about the original IBM XTs, the 8086, 8088 computer era, right? Those machines only had floppy drives. They did not have hard drives initially. To add a hard drive, you'd have to put an add-on card, but there was no BIOS support because they just weren't a thing yet, right? You can load what's called an option ROM. Certain cards, you can put a little ROM thing into it, which boots up. Like if you've ever used a SCSI adapter or like a RAID controller, you know that when the system boots up, like these old computers, it will read the BIOS and go through some configuration before it boots the operating system. There's this device called the XT-IDE, which was a little IDE adapter with a ROM chip on it, that ROM chip would boot up and basically have the IDE functionality on it, and then from there would access the IDE port on that specific card. This motherboard, however, has IDE built into the motherboard. And there's only 4 ISA slots, and we don't have a lot of things built into the computers back then like we do nowadays. For instance, I want to put a network card in this machine. Well, a lot of computers today either have Wi-Fi or Ethernet built in, so you don't need an add-on card for that. This one I do. Same thing, sound card. This machine actually came with a Sound Blaster sound card, but that's another one of the slots. Another slot I have dedicated to a modem right now because I want to play around with some home-based dial-up software and maybe set up a BBS that I might actually make public in the future. And then the fourth slot is going to go to a SCSI adapter, which I guess I can always use SCSI hard drives, but those are kind of expensive. I'd rather just use cheap CF cards I can get all over the place. Anyway, it turns out that the XT-IDE BIOS will work with other IDE controllers, such as the one that's built into this motherboard. And on top of that, you can actually, instead of having a network boot ROM, you can simply flash one of these chips, put it onto your network card, and your network card will then act as your IDE controller BIOS. Wow, like, I am blown away that that's a concept. I didn't even know this was a thing until I started doing research with this machine because I never needed this back in the day. All right, but I said that my CF cards are right around 500 megs. They're actually slightly below the cutoff limit for this BIOS. So why am I going through all this trouble? Well, there's actually two reasons. So first off, I actually have a stack of 2 gigabyte CF cards in the mail right now. And those ones are the same as these, where they're the Western Digital Silicon drive. So I can tell you right now that these things work great, at least the 512 meg ones do, so I hope the 2 gig ones do as well. So those are a little bit too big. But secondly, even more important than that, is compatibility issues. It turns out these CF cards working directly with the BIOS on this machine don't quite like each other yet. I can't say for certain if this is the exact issue that these cards run into, but it's plausible, and this is a bit of an issue from this era. Essentially, I believe these drives are actually too fast for the way the BIOS was coded. When I was installing Windows 3.1, I was getting I/O errors trying to write to the drives. You see, when you try to write to the drive, that sends a request to the BIOS. The BIOS runs a little bit of code that actually pushes out the commands to tell the drive to store the data somewhere, right? And then there's a second command after that that says, hey, when you're done writing, let me know. That way I can return back to the application so the application can do the next thing, like the next block of data, the next file, whatever it's doing afterwards. But you notice how I said that there's two operations there. One is to write the data, and then the other one is a request to say, hey, let me know when you're done. If you're dealing with a spinning hard drive, you have a mechanical head scanning back and forth to figure out where it needs to write. And then you have a second process, which is the disk spinning itself. It has to physically write the data on that track as it spins. And so that takes time. And that time can be measured in multiple milliseconds, which, for us humans, that seems super fast, but in terms of computers, that's slow as hell, right? CF cards, they're SSDs essentially. I mean, literally SSDs, just in a different form factor. So they don't have the limitations of seeking to a track and then the rotation of that track to be able to write the data. They can write this data very, very quickly. And I believe what's happening is there's the command being sent to write the data, and then while that data is being written, on a normal hard drive, that would take time, but on this one, it's done almost instantly. And then the second command is issued saying, hey, let me know when you're done, but the drive is already done before the second command actually even hits the drive. So then, since there's nothing pending to be written at that current state in time, the drive is sitting there like, well, I'm not writing anything, so I don't have any notifications to send. And then the BIOS is sitting in a state where it's like, okay, I'm going to have a countdown timer. If I don't get any confirmation within a certain period of time, let's say 5 seconds, I'm going to error out and say, hey, something went wrong with this write. So because those two commands are happening in that specific order, the BIOS is just giving up saying like, hey, I didn't get that signal back saying that you wrote successfully, so I'm going to think there was a write error and I'm going to fail. Back in that day, like, yeah, that's technically a bug in the BIOS, but there was no hardware in that era that would trigger that particular issue. But, with me using these faster drives, that is a problem. So when looking at things like XT-IDE, it replaces the BIOS calls that are used to write to the disk. And so those calls can be reversed, where it's like, the first call is like, hey, I'm going to send you some data, let me know when it completes, and then it sends the data. That way it gets that notification back and it can return back to the application instantly without any I/O errors whatsoever. And so because of that, like I said, I was getting disk I/O failures on these CF cards trying to install Windows 3.1 on it because of, I'm assuming that was the issue I was running into. All right, with all of that, let's actually get into the process of how do we do this? How do we get XT-IDE onto the ROM that we can put into this network card? So I've had the boot process paused here at the beginning just to show the Mac Store screen, but let's go ahead and continue finishing this boot process, and then I can run a couple commands to show you basically information we're going to need going forward. All right, so I'm going to go into, I have Check It Pro installed, but there's many different programs you can use to check your memory layout of your machine. All right, so I'm loading Check It Pro right now, and it's going to go through and analyze the system. Most of this we don't actually need. What I'm going to do is I'm going to go to Memory and Base and Upper. So like I said, this is the 1 megabyte memory map for MS-DOS. Anything above 1 meg we don't need to worry about. It's just specifically in this section is the only thing we care about for this particular process. And the base memory we don't need to worry about. So we can just scroll down here, and as I'm going through you can see it's highlighting different sections of the base memory we don't need to worry about. It's upper memory that we care about the most. So VESA graphics, we want to bypass that. VESA text, VESA color. So these are different things stored in this section of memory which is specific to the video card, and we want to get past that. Same thing with video ROM. We don't want to conflict with the video ROM. Programs are loaded in dynamically, so this address here is actually the first address that we can use onto this 3COM card, which we'll have to configure here in a bit. This particular card has a graphical utility for configuring it. Other cards may have jumpers that you set, but this is how you pull the information that you need for it. So as we can see here, the very first address is C800, and that's what we need to write down. That is the important thing right now. However, any address that's in this available section can also be used. However, I'm going to use C800, that way it's right next to the video ROM. That way there's no gaps, and then all the programs will just dynamically load after this ROM that we're putting onto the system. So that's all we needed this application for. We need to download the XT-IDE BIOS off the internet, as well as the configuration utility, and we're going to put it onto a floppy disk. I've already done that, so I have my XT-IDE floppy drive here. Ha, I did that blind, cool. So I'm going to go to my A drive. I'm going to go dir and see how there's the XT-IDE CFG utility. So XT-IDE CFG, I'm going to go ahead and run this. So the thing is with the BIOS that you download online, we can't just directly flash it to one of these flash chips. There's two things missing from it. One, there's a checksum that needs to be there, which, yeah, we can go ahead and calculate that ourselves and put it in there, but that doesn't actually quite make it work. There's also the configuration. So if you think of your modern BIOS today, or even the built-in BIOS into this machine, there is the flash chip that has the code, but then there is RAM or NVRAM, depending on the type of system. These old systems use actual RAM. That stores that configuration. So when you make a setting change, it saves it to RAM, and then that RAM is stayed powered by the battery in the system, which you're probably used to using like little coin cell, like 2032 batteries. That keeps that RAM powered all times 24/7. That way those settings stay intact, and if you pop that battery out, you lose your settings. That's why that is. You're actually basically getting rid of the power to a chunk of RAM. Since this is a ROM, and we only have a ROM, we don't have RAM to work with, we actually bake the settings directly onto the ROM, making it non-configurable. To do that, we can configure that ROM ahead of time with the settings that we want, so that way it already has what we need. It just means that once it's installed, we can't change it. We'd have to reflash the ROM chip entirely. So what I'm going to do is load BIOS from file. In this particular case, I'm using the 386 large bin file. The reason for that is that there are 8K ROMs, or this one is a 12K ROM. That's important because it's determined by what type of ROM chip you're using. If you have an 8 kilobyte ROM chip, you're going to need to use one of the smaller ROMs for that. But if you have a 16 kilobyte or larger ROM chip, you can use the large file here, which has a few extra optional features enabled onto it. I'm going to go ahead and load that file. I'm going to hit enter. What I can do here is configure XT-IDE Universal BIOS. And what I'm going to do is I'm going to use the auto configure. And it found one controller. Basically, if you can have up to 4 IDE controllers into a system that this supports. So this will go and try to detect which ones they are, and also it'll try to detect what type they are, as well as what address they're at. Instead of trying to figure out all of this information on your own, this will auto-detect all this for you. If we go into the two different ports on the IDE channel, you'll notice that this should be set to automatic already. So it'll try to auto-detect if there's a device plugged into it or not. At this point, there's nothing else we really need to do. Just doing auto has exactly what we need. Some of these other configurations you can go and change if you need to, such as like the upper memory block, or if you want to, use some RAM for variables, whatnot, once the system is booted. But in my case, I'm just going to leave everything default, and then I'm going to go back to save BIOS back to original file. And what that does is it rewrites the file on the floppy disk with all of our configuration changes as well as that checksum data. So that way, this is now a complete ROM that we can dump onto a ROM chip. All right, so let's get this powered off, and we're going to switch over to the desktop. Before we can actually flash this chip, we actually have a problem with the chip itself. I'm using a 64 kilobyte chip, but like I said, we only need a 12 kilobyte ROM. Things are done in 8 kilobyte chunks, which means we have to round up to 16, but 16 is a lot less than 64. We can actually fit 4 of those 16s inside of 64, and that's a very important number, that number 4. All these different pins on the flash chip, there's a section of them that are for addressing. There are 16 pins that handle the addressing, 0 through 15. Each pin toggles on and off to become a binary value to basically give you a digit between 0 and 65,536, which is at 64 kilobytes, right? Well, this 3COM card isn't designed for 64 kilobyte ROMs. It can do 32 or 16 kilobyte or 8 kilobyte ROMs. But that means that we have 1 or 2 extra floating pins there, because we're going to set this to 16 kilobyte mode. So that means we have 2 pins at the very end, pin 14 and pin 15, that are either left floating or they may be pulled higher or pulled low when we need it in the opposite direction. So when we go to try to retrieve data off of it, it may be pulling from the wrong chunk of the RAM. It may be pulling from offset 16K instead of offset 0, or offset 32K instead of offset 0, and so on and so forth. We can either modify the card with some pull-up or pull-down resistors, or we can simply just handle this in software itself and just say, hey, each of those 16K chunks, all 4 of them, have the exact same data, so those last 2 pins, regardless of what they're set to, if they're high, if they're low, if they're floating back and forth between the two, will always pull the same result from the ROM. So what we have to do now is actually duplicate this ROM 4 times over, and I'm going to use a program called HXD. So first thing I'm going to do is I'm going to open up our ROM file. So this is the IDE 64L file that we saved from the floppy disk. And here's the file. We don't need to worry about all the hex values and everything like that with it. What I'm also going to do is create a new document. And in this new document, I'm going to go insert bytes. Specifically, our byte count, it's set to hex. I'm going to do 4,000 hex, and that's 16 kilobytes. Right here it says, so this operation will change the file size. Do you want to proceed? Yes. I want to insert 16 kilobytes worth of information. So I'm going to go back to our first document here. I'm just going to go edit and select all, and then I'm going to go and copy that. Now I'm going to go to our new document, this untitled one. Let's go to the very, very top. Let's put the cursor at the beginning. You can see this at the bottom. I'm at offset 0, and I'm going to go edit, and I'm going to go paste right, not paste insert, but paste right. So this will overwrite the zeros that are already created. And so now we have the same contents, but if we scroll down, instead of being just the 12 kilobytes, we have all these extra zeros padded at the end here. So now what I'm going to do is I'm going to go edit, select all, and I'm going to go to copy. So now we have that as a 16 kilobyte chunk copied into our clipboard here. And now I'm going to go and edit and paste insert that at the very, very end. Notice how I have the selection at offset 4,000. And once again, it wants to increase the size of the ROM. We are now offset 8,000. I'm going to go edit, paste insert. So this is now our third copy. And I'm going to go edit, paste insert. And with this, we now have 4 copies of that ROM data in here. As you can see here, we have the contents at the C000 offset. And if I keep scrolling up, here's another copy starting at that 8,000 offset. can see that we have multiple copies of this ROM data. So with this file, I'm now going to go File, Save As, and I'm just going to call this XT-IDE.bin, and I'm going to save that. With that, we are now done with the hex editor. So if you notice, we didn't really have to do a whole lot of complex stuff. We just had to create 4 copies of this and have it specifically at a certain size. So now that we're in the XG-Pro software, which is used for flashing the firmware onto the flash chip, I'm going to go Load. I'm going to paste in the path here for our XT-IDE.bin file. And from there, I'm going to hit OK. And now we can see the same hex contents is now here inside of this file on the screen. And then from here, again, there's nothing here we need to do. We don't need to worry about what those hex values actually are. I'm just going to hit the prog button, which is short for program. This will actually send the information over to the flash chip. And this right here shows a diagram of how to put the flash chip into the socket with the pin orientation with the dot, the cutout, and the direction of the pull handle, so you know which way this chip should go in there. What I'm going to do now is to hit program. This takes a few seconds. And then also it will read back the flash to validate that what it wrote was actually what it should be. So it did a full write, and then it did a full read and compare the two to make sure it's the same. And everything checks out, it's good. All right, with that, I'm going to take the ROM out of the flasher here. Let's pull this out. And I'm going to put this into the card. Now make sure there's a notch on the card here that says where this notch lines up. I already screwed this up once. I put in the chip backwards, it overheated and fried itself. It is dead. So this is actually another chip of mine. Luckily I had an inventory of them. But yeah, we just insert the chip here, and now I can go and insert the card into the computer. All right, let's get this card into the machine. So next up, we actually have to configure the network card, because you notice it's still booted just like normal. There's no XT-IDE stuff booting up. So this being a 3-COM card, I have the 3-COM disk here, like this totally normal, legit commercial 3-COM disk. This is the Etherlink disk. So what I'm going to do is I'm going to go ahead and put that into the floppy drive there, go to the A drive, and I'm just going to run the install utility, which I'm not actually going to do any installation. This just gives me a quick, easy menu. Notice down here we have something called Configuration and Diagnostic Program. So let's go ahead and run that. In the menu here, we have Configure NIC. So I'm going to go there. As we can see, if I tab over, boot PROM, or in this case, you know, the ROM that we want, the PROM, programmable ROM, is currently disabled. So what we need to do is we need to set this to 16 kilobytes, because that's what we're working with, remember? We're dealing with 16 kilobyte chunks. And the address that we were looking at was C800. And this shows an extra 0 that doesn't matter because, you know, there's actually several zeros there. All we care about is that the first chunk of it is correct, and C800 is what we expected to be able to load this into on this particular machine. So I'm going to have both of those selected. I'm going to hit OK. And then down here, I'm going to go to OK. Right here, we get a warning, but in this particular case, we know what's in that address bank. It's the other program stuff, which will get shifted around because this will be loaded before those programs. And on this particular case, it's OK. I'm just going to reboot the machine. We're going to go through the normal boot up process just like before. Would you look at that, we have XT-IDE loading now. I hit F2 to load in the boot menu, that way we can stop and pause on the screen, but anyway, we can see very clearly that the MaxStore hard drive that is plugged into this machine is now perfectly detected and working. All right, where was I? I don't remember because the camera lost power and it's a couple hours later now. Woohoo! Anyway, we can see here that when booting up the computer, we are now in the XT-IDE interface. You can see the MaxStore hard drive perfectly detected in here. Press the button to come to this menu rather than having the system auto boot. Normally it would just boot off the hard drive because that's how it's configured, but I wanted to pause on the screen to show this menu just to show that A, we can boot from either floppy drive, and this can actually invert the 2 floppy drives, which is nice. Or B, I can just go straight into the hard drive. Or 3, if there's other boot ROMs on this machine, I can actually swap to a different boot ROM. Anyway, let's go into the MaxStore, which is our normal drive, and just boot like normal. The dynamic drive overlay software can now be uninstalled because we don't need it anymore thanks to the XT-IDE. They basically do the same thing. But anyway, once this boots up, I'm going to get back into check it so we can see what the memory map looks like. Since, remember before, it said that was program RAM that is now going to our ROMs. So what does our memory map look like now? Base memory, again, we don't care about. And we get to the upper memory, just like before, there's the VESA graphics, VESA text mono, VESA text color, video ROM, and then all of a sudden we have adapter ROM in this space here at C800, just like we configured on the 3COM card. And if we go down one more, programs now starts at CB00. So like I said, since those are dynamically loaded once DOS is actually loaded, they go to wherever the next free space of RAM is. They're dynamically allocated. We don't have to worry about overwriting those. And they fit perfectly in right where they were before. And now we still have 40K available RAM in our upper RAM section. So I believe that was, what, 56 before, something like that, which would make sense because we use 16 kilobytes of it for this. Even though it says it's 12 kilobytes used, it's in a 16 kilobyte chunk because everything is in 8K chunks. So there you have it. We have XT-IDE installed on this machine through a 3COM Etherlink 3 card using a 64 kilobyte ROM chip. There's been a lot of discussions on various forums, like the Vogon forums, whether this is possible or not, or other people having issues. And it took a considerable amount of research to figure out how to get just the right combination of things together to make this work. There's other tutorials online, and each one is missing like one or two steps here and there. So I wanted to bring the whole thing together. Specifically like building the ROM using the floppy disk and then going and making 4 copies of it before putting it on the actual ROM chip. Both of those steps there were quite important in making this work, and some tutorials had one, some tutorials had the other, some tutorials had neither. I noticed a lot of tutorials already had a ROM chip built, and they're like, oh, you just put it in the socket and it just works kind of thing, and then you configure the card, without actually talking about the process of making the ROM chip itself. I wanted to show the entire process beginning to end because none of the information I found online actually showed that entire process, and it took me like 6, 7, 8 different pages worth of information to figure out how to get this working, and that was a whole day endeavor. So now it's all in this short little, probably 10-minute video, and you can go ahead and do cool stuff on your computer, like, you know, run Windows because you got plenty of storage. And then you install After Dark and have flying toasters, because really, I mean, that's the whole reason we're running old school computers, right? Is to watch some good old flying toasters. I do plan to have more tutorials and more videos revolving around this computer because I have done a hell of a lot more to it, and I have more parts in the mail right now as well. The whole reason I wanted all of these drives, like I said earlier, is so I can have something like 8 different operating systems and quickly swap between them. And so far, what little testing I've done, that is working. I'm just waiting for more drives and another controller card to show up. And when that does, I'm going to be installing all sorts of things, and I want to document a lot of it to show what we used to do with old computers back in the day, because this is the kind of hardware that I grew up on, and it's a fun nostalgia bomb for me. But anyways, until next time, if you have any questions about this, or you want to get this set up yourself, or you think this is awesome, you know what to do, and drop a comment, and I'll see you in the next one. Later, all.